Hi, so this is the schematic of the design. So here we have our sensor. So this timer it generates an output at this line here, and this is the exact point where our sensor is connected at. So this line, this is where our sensor is connected. And let me show you from the layout. So this is the point that our sensor is connected here. So sensor one, it goes to So this is the point of sensors connected at. So what happens is that this is the timer chip that provides a clock signal. And this part here, the capacitor and then the sensor, which is this copper filler here. So this is the ground copper filler, and this copper filler is the sensor copper. So what happens here, this ground copper filler and this sensor part, it both works as a capacitor here, this part and that part. So here we have, and in combination with the resistor, 10K resistor here, this sensor and the resistor, it works as RC filter. And based on the capacitance, the output here changes, and thus it changed the sensor output value. And this sensor output value, it goes to pin IO34, and IO34 is the IO34 of the ESP32 microcontroller, which is the ADC input. So this ADC input and this 100 nanofarad capacitor makes sure to smoothen the ADC data that is coming in. It makes it more stabilized. So and there it get fitted into the IO34, and then we are reading IO34. And this is our I2C based temperature and humidity sensor. And this part is a voltage converter. So what happens is that we connect the battery to one pin and it generates an output of 3.3 volt. This is the LDO, which is a low output voltage regulator. So this is about the schematic. So in the layout, if I show from the layout, so this is the positive. So this is the positive of the battery is connected to, and this is the negative of the battery is connected to. And this power of this goes through this LDO, and the LDO it powers the timer 555 and also the ESP32 and all the other parts in the circuit, as well as the sensor. So what happens is that let me show the 3D first. So this is our layout. So what happens is that when it makes a contact, and then when we touch here, or when the soil or the water gets in contact to it, it makes a combination, and thus it changes capacitance value from this line, and then it gets fitted into here, the RC filter here, and based on this, it changes the output value, which is being generated from the timer IC. Okay, so now we look into the simulation. So this is our simulation part. So this is the simulation part. Now you can see, let's say, so C3 is here, this sensor here. So C3 is the C3 capacitance is this sensor here, since it works as a capacitive soil moisture sensor. So what we're going to do is now we're going to play with that. So 1.7 volt or 1.8 volt is something that when there is like really capacitive, then it makes this value. So when the capacitive value decreases, now you can see a changes in the so now you'll be able to see some changes in the output value. So the green line is this line here, the line or the junction where the RC filter gets in series to it. And the blue line is the output, which gets fed into the ESP32 microcontroller. So let's say when it's raining, when the moisturizer it changes its value. So this is what happens. So now you can see a hike. So it will be increasing and increasing. So this is how it looks like in real time. So you see it's increasing. So let's say now when the sensor, the moisturizer changes. So when the moisturizer changes, it changes the capacitance. So when the capacitance changes, it decreases the value. So this is what happens in real life scenario, and it will be decreasing the output voltage. And then based on like how we want our voltage output to be smoothed, we actually can decrease the output capacitor value, and then it will be changing its data output very sooner than it should with 1 microfarad. But you can see one table is about 1 microseconds. So in real life, we don't see a delay like this. It goes down very smoothly, very quickly. So yeah, so this is about the simulation, about how the sensor works, Thank you very much. And this is about our project.
So this is the soil moisture device, which is still functioning. So we are powering it up with the power supply behind it. And so here it's a capacity, we have made a capacity sensor here, and it's connected to the RC filter here, which is being feeded by the microcontroller, and the wave is generated by this timer 5555 chip. And so this is the one with the soil, which is we have about 15 to 20% moisture. So now we are going to add some water and we'll see the result. So at present we have added water to the soil. We have added about 100 milli of water here. So I believe the current data output, it should be about 60 to 80%, or it can be a bit more. And now we'll be seeing the data on the web. Thank you. Okay, so now we can see the data here. Okay, so this is the data of the last hour. So we can see the temperature, the last updated was at 3:39 o'clock. So we had about 30 degrees Celsius. The humidity was about 65%. And we can see, so this is the moment where we initially put our moisture, so about 15 to 18%. At that range we can see it about at 15-18. And then when we included the water, so that was about, you can see about 80 to 78, 79, 84%. And then when we took out the sensor from the ground, we can see there has been a decline, and it became to like, about 7, 9, 10% at that range. So this is the data that we are getting.